Welcome, everybody. We'll get started in a couple of minutes. Welcome, everybody. We'll get started in 1 minute. Thank you for joining. Hello, everyone. Welcome to today's virtual conference, Why Open Source Software Powers Innovation at the Edge, brought to you by IoT World and sponsored by Influx Data. I'm Lucian Fogoros. I'm the co-founder of IoT World. And on behalf of my team, our sponsors, thank you for joining. Linda Hall on my team will be monitoring the online channel, so feel free to send your questions in the Q&A section or via the social channel leveraging the hashtag IIoTAI. I'd like to introduce our moderator for today, Greg Orloff, who will host our virtual conference. Welcome, Greg.
Thank you, Lucian. Good morning, good afternoon, and good evening, everyone. And once again, thank you for joining us. Now, before we dive into today's material, please allow me to give those of you who are joining us for the first time a little bit of background. IIoT World is a digital media publication that covers the economic and technological implications of the transformation taking place as industrial IoT proliferates throughout the enterprise. IIoT World combines journalistic coverage with data analysis to expose the stories, players, trends, and innovations that shape the IIoT. IIoT World was recently ranked by K-Core Analytics as the #1 global influencer on several topics that include industrial IoT, smart manufacturing, ICS security, SCADA, predictive analytics, and predictive maintenance. Additionally, Smart Cities has been in the top 5 position for the last couple of years. Our mission is to help companies create a culture of innovation and connect the smarts, industrial technology, manufacturing, sensors, and the CXO decision makers who seek these solutions. Today, we have an intriguing panel with representatives from Influx Data, IoT Council, and the Eclipse Foundation that are poised to provide keen insights into leveraging open source to drive innovation at the edge. In this virtual conference, the stereotype that open source IIoT historians are a poor alternative to proprietary software will be shattered. Our speakers will examine what existing closed source historians lack and review leading open source projects to consider. They will also provide examples of how open source is becoming a standard in IoT and explain how companies can use it to their benefit. Key topics that we will cover today span the vast range of sensors and devices to collect data from and why it's too broad for any single commercial vendor to support. How open source software historians let you connect a broader set of sensors and devices to time series data historians. IoT is real and adoption is growing, if slower than the hype would indicate. Just under 40% are deploying IoT solutions today, and another 22 plan to start deploying IoT within the next 2 years. And open source is eating IoT, with 60% of companies factoring open source into their IoT deployment plans. And we will also touch on potential combinations of open source software for IIoT edge use cases. So I'd like to kick off our session today with IoT commercial adoption, an overview of current trends with Frédéric Desbiens. Frédéric is an IoT and edge computing program manager at the Eclipse Foundation. His job is to help the community innovate by bringing devices and software together. His domain knowledge, skills, and experience in open source, IoT, cloud platforms, and activity in social media are great assets to executing on the strategy to grow Eclipse's IoT engagement, awareness, and commercial adoption. Frédéric's prior experience includes roles with Cisco, Oracle, and Pivotal Software, where he was a contributor to the Cloud Foundry open source Bosch project. Frédéric, the floor is yours.
Thank you very much. And thank you everyone for attending the conference and my talk. So today we will review together essentially the key findings of the Eclipse 2019 IoT Commercial Adoption Survey. That survey, it was literally the first edition that we were conducting of it last fall. And essentially we had very, very good turnout for it. So we had about 366 individuals, business deciders that took the time to answer our questions. And the whole goal of the survey was really to understand, the IoT industry landscape by identifying the requirements, the priorities, the challenges faced by organizations that actually deploy and use commercial IoT solutions today. This new survey is a complement to the annual developer survey that we conduct at the foundation every year since 2015. And I'm sharing the key insights here, but certainly we have more information available on our website about this. So let's get forward since we have limited time and look at the first takeaway. As it has been mentioned earlier in this on this call, IoT is real and adoption is clearly growing in the market right now. So we have a plurality of respondents to our survey. So just under 40% that are working with IoT solutions today. And what's meaningful to me is that a whole, up to 22% will start doing it in the next 24 months, which means that they are conducting POCs, they are conducting or exploring market solutions at this point in time. So literally the question is not whether IoT will be a reality, but when, and the when is literally now. Only 10% of respondents have no plans to deploy IoT solutions at all, which to me is really, really significant and shows how broad the reach of IoT is. Our second takeaway now, okay, it's one thing to say that you want to deploy IoT solutions, but how much money are you willing to put into this? And here it's very clear that companies are still, at the beginning of their efforts, at the beginning of the cycle. 30% of respondents to our survey will spend 100K or less, in the next year. And at the same time, you see that 5% of respondents will be spending 10 million or more. So really, we see that there is real money to be made, and real money that will be invested, obviously, in IoT solutions. But that, for the time being, caution is certainly key. At the same time, we see, and that's the takeaway number 3 that we have, that most organizations plan to increase their investment in IoT solutions for the next fiscal year. So the level of investment for the time being is, well, we could say fairly low, but at the same time, most companies are convinced of the value of what they deployed, and that's why we think they will be increasing their investment in the next year. And a whole 21% of the respondents told us that their level of investment stays the same. So essentially, since only 3% of respondents say they will decrease, to me this tells the story that the deployments that have been made and the POCs that have been conducted have been successful. Takeaway number 4 now. We asked to the respondents of our survey what industrial categories best describe the type of IoT solutions that they have deployed or will deploy. And here, you see, if you look at the top 3, energy management and building automation, connected smart cities are really one big focus there. And to me, this connects to the trend of climate change, in the sense that if you manage energy properly in a city or inside a building, and obviously there are savings that key there, then you can fight climate change in a very, very effective way by deploying IoT solutions. Not only that, but if we expand, to the top 5, so industrial automation and agriculture. Industrial automation, certainly IoT has the potential to reduce waste, to reduce lead times, and overall to make factories more energy efficient. And agriculture, smart agriculture, is all about minimizing waste, minimizing unneeded irrigation, minimizing fertilizers and stuff like that, so that you use them in a more effective way. So once again, this has a direct connection to a better environment and to climate change. And that's just the top 5. I mean, our respondents mentioned several other categories, but certainly to me, it's really, really interesting that the top 5 categories that have been mentioned by our respondents all have a connection directly or indirectly to the fight against climate change. The 5th takeaway from our survey. So we asked survey takers essentially what were their plans to use open source for implementing IoT solutions. And to me, the one result or the one figure on this slide that's really talking is the fact that only 14% of our respondents are looking at purely proprietary or closed source IoT solutions. So to me, this demonstrates that open source, literally won the battle, so to speak, for the hearts and minds of technologists and not only developers, but business deciders as well. And to us, it makes a lot of sense, obviously, because at the Eclipse Foundation, several of our members have open sourced basic building blocks that anybody can use in order to build IoT solutions. And then they are offering commercial solutions on the top of that. Bosch and Eurotech, for example, are 2 good examples of that business model that we have at the Eclipse Foundation. So to us, the results in our survey just vindicated our point of view that if you want to do IoT the right way, you need to do it the open source way. And so 60% of companies right now are factoring in our survey open source into their IoT plans. And we think that this trend, this number will be even higher in the years to come. The 6th finding from our survey. So we asked people, what is their preferred pricing model for consuming IoT platform services? And here, really, the per device model was the clear leader. Although, I mean, an hybrid model found a number of fans in our survey as well. That said, it's obviously difficult there well, we need to go deeper. I mean, we have a clear finding there, and I think it's interesting. But what we will probably do in next year's survey will be to have a look at, okay, we see per device, but how many devices are you deploying there? Is that 1,000? Is it more? So certainly I have the feeling personally that as it could be interesting to correlate the answer to that question with the size of the deployments that people are doing right now. And in the current version of the survey, we don't have that data. So for us, it will be interesting to dig deeper and probably we'll have you know, an even more precise view on where the market is headed in next year's edition of the survey. 7 takeaways. So how would you describe your IoT cloud strategy? And here, well, we see that most people, at least a majority of people, will use the hybrid cloud model, whereas only 20% of respondents in our survey will say that they use exclusively a public cloud model in order to deliver IoT solutions. And to me, this is only normal because, well, depending on what kind of data you're working with, but there is certainly a resistance against putting, you know, business sensitive data entirely on the public cloud for data sovereignty reasons, for security reasons, and a flexible approach there to the cloud backend is certainly what is needed. At the same time, it seems that most respondents to our survey don't necessarily have a lot of interest towards the multi-cloud model, where essentially you would combine, you know, several cloud providers wherever they are, you know, their own IT team because they operate a private cloud or some external players. So it seems that most respondents at this point in time will devise a cloud architecture and stick to it and not necessarily involve multiple clouds in the mix. Takeaway 8, how would you rank the importance of the following technology components in our IoT solution? So when we look at the orange part of the bars that we see right now on the screen, sensors are certainly, and cloud platforms are the #1 and 2 concerns here. But edge nodes, when you combine the 35% of them that say it's high importance, and then the 37% of people that tell us this is medium importance to them, you can see that there's a growing trend around there. And to us, this is really significant because edge obviously is not at the same point of the hype curve as IoT. And what we see in our own community at Eclipse Foundation is that several of the players we have on the IoT side up to now were, you know, staying on the fence about edge, but now they are ready to make, you know, to commit to it, and they are starting to leverage it in a more meaningful way. And that's why in December of last year, we launched the Eclipse Edge Native Working Group, where people, players like Bosch, Siemens, Eurotech, Intel, Huawei, and others have come together in order to build, well, or I should say to steward the 2 open source edge computing platforms that we have at the Eclipse Foundation. Takeaway 9, so we asked respondents to our survey what are the top 3 cloud platforms that they intend to use for IoT implementations. And obviously, we are talking here about public cloud platforms or maybe hybrid, because some of them give you the possibility to install, you know, to have local nodes in your data center as well. And no surprise there, I mean, the big 3 of the cloud, so AWS, Azure, and Google have taken the top 3 spots in the responses. And I must say that when you look at the full data set for this question, I mean, the other players in the market were just left with crumbs, literally. So those 3, you know, eat nearly, at least in our survey, all of the potential market in that space, which doesn't mean that other players don't have a play to make, but they will probably need to provide some differentiation and focus in order to be successful. Takeaway 10, so we asked respondents to name the most important industry groups in their minds related to IoT. And in other words, what are the industry groups that they are looking to in order to determine their IoT strategy? And Eclipse IoT came on the top, followed by the Apache Foundation and Linux Foundation. But in this case, I must say there is probably sort of self-selection bias in the sense that this survey was sponsored by the Eclipse Foundation. But at the same time, I mean, we had quite a big number of respondents that came from outside our current ecosystem. So, you know, I wouldn't completely discount the takeaway that we see on the screen right now. Takeaway 11. So what are the top 3 concerns and priorities for deploying IoT solutions? And here, security obviously is at the top. It's been consistently the top concern, even when we consider our annual developer survey that we are conducting since 2015 at the foundation. And so performance and data collection and analytics took ranks 2 and 3. To me, this is meaningful because performance as number 2 is really showing the growing importance of IoT. When you do an initial deployment or a small POC, you don't think about performance that much. I mean, you obviously keep an eye on that, but you are much more focused on delivering business value. So the fact that performance is number 2 in my eyes shows that IoT usage is growing and people are getting past the initial implementations and now need to optimize whatever they are doing and whatever they have to the field. And obviously, this is the top 3. So there were other concerns and priorities that were mentioned in the survey, but those are the top 3 that were mentioned by the respondents. And this is the end of this short overview of the findings. We have more data in the survey, and obviously respondents, for example, mentioned connectivity and stuff like that, but this is something that we can explore maybe in the Q&A later. So thank you for listening to me, and if you want to learn more, you can visit our website, iot.eclipse.org, not .com, and connect with us on Eclipse IoT on Twitter. And we are always on the prowl for new members for the foundation and our working group, so we can get in touch with you if that's of interest to you. So thank you for listening once again, and thank you for the opportunity, Lucian. I'm really grateful for it.
Thank you, Frederick, for sharing. The point that stood out to me is I think the growing interest at the sensor level as well. I think we're going to see a groundswell around that activity in the months and years to come. But thank you for an enlightening presentation. And once again, feel free to join the links that Frederick shared with you. So our second speaker of the day is Mr. Rob van Kranenburg, and he'll be presenting his session entitled, Edge is the Natural Way to Go, On Device, On Chip, Identity as the Key. Rob is the founder of the IoT Council, a bottom-up IoT ecology accelerator, IIoTday.org, and he currently ranks number 10 in the top 100 IoT influencers. Rob is a published author of several books, including The Internet of Things, a critique of ambient technology and the all-seeing network of RFID, Network Notebooks 02, Institute of Network Cultures. Together with Christian Nold, he published Situated Technology Pamphlets 8, The Internet of People for a Post-Oil World. Additionally, Rob is co-editor of Enabling Things to Talk, Designing IoT Solutions with the IoT Architectural Reference Model, published by Springer Open Access. He is also co-founder of Brico Labs, an association that holds weekly meetings to collaborate in the design, construction, and testing of IoT-related devices and gadgets, and works as ecosystem manager for the EU projects TaggetSmart and Next Generation Internet. He is a DATAO Master of IoT. Rob, welcome to the virtual conference. The floor is yours.
Well, thank you very much for having me. And thank you also for listening all that stuff. I'm getting tired of it myself, but hearing all that. But I think as you can all imagine from those titles, my background is not really technical. And so with council that I set up about a decade ago, it was really about looking at the societal implications of what we see now as data-driven governance. And so yes, what I'm going to discuss now is basically identity and how this has become, after platforms and data, the new frontier. Lucian, can you do the slides for me? And thank you. So yes, in 2011, Christian Nold and me published a text that was then seen as quite romantic and naive, as we had some ideas and some rules about systems being designed by sort of 20 people being built from 150 miles away from where the original, where they were located, and components that were not only backward compatible, but allow for local repair and upgrade and downgrade. And this thinking that we had, seeing sort of peak oil, also lots of issues, social issues, and lots of things, and the transfer of large resources to companies, as we also see in the cloud figures that we just saw. And of course, as we are now basically all locked down, I guess, with the virus, this kind of thinking becomes more natural, to keep things close, to have systems that are repairable, that are locally repairable. And so this notion of going to the edge, which was always a logical notion in predictive maintenance, as from the 50s and 60s and 70s, and automation, when Internet of Things was still being called pervasive computing or ubiquitous computing or basic automation, it was always the edge, because it was always local factory computing. And then on the left, there is this, what to me is beautiful picture by Stafford Beer, who in his writings and also actual doings on cybernetics has this kind of image, which basically says that anything has to be handled locally, and then if you cannot handle something, you go one step up. And he has this beautiful notion of the algedonic signal, which is that signal that cannot be handled locally, or one way up or one way up. And only those signals go to some kind of a situation which we can now maybe call cloud, but maybe we can also handle that locally. So you can go to the next slide. So basically the arguments that we had there was that peak oil, social injustice, climate change, and flukes like the virus, or maybe not a fluke, but let's call it a fluke now. They call for local repairability because infrastructures can, and as we can also see in certain places of the world, break down. And then having really important decision making somewhere else, or somewhere where you can actually not touch it, is very problematic. And what's called the edge is basically an equivalent for serving everyday needs, where resources, and this is our taxes, where our taxes go, should be available. Of course, the cloud until now supports online shopping, communications, all these things, as long as the old services and infrastructure work. So basically, as long as your local hub sort of works, all the rest may still work. But if the local hub breaks, then it's very difficult to go beyond that. Now, what I've been busy with the last 2 years, especially also working in these European projects, is setting up workshops on identity, because identity is becoming the new frontier. So we've seen the platform wars, and if you look at the figures that we just saw of the cloud market being taken by Amazon, and of course we have Alipay and sort of all of these, that's sort of pretty serious. If we look at the over-the-top situation of the services market, Uber, Airbnb, we also see that this happened extremely fast. But the next fight is on identity, and national governments are outsourcing identity. If you can just go a little bit back, yeah, then to the other slide, yes. So therefore the key is that we have self-sovereign identity systems, and that we have a lot of them. And basically that's the idea, that's where we should go. And we should run this also locally on a device. And the AI data management layer can also happen on that device. And that's basically where we see a lot of things going, because people want to keep agency close. Yes, next slide, please. So what we see basically in Europe is that we see commercial providers offering the 5 layers, which is GDPR, ADAS, PSD, PSD2, there's a D missing, AML and Certitrust. And what we're proposing and what we're seeing is that a lot of this will go basically on the chip itself. So we see the Microsoft Cloud chips happening, but what we will mostly begin to see is that security will be embedded on the chip. And this is also how we see identity. So that identity will be on the chip, it will be all these legal requirements, and then it will also have another layer, which is behavior. And that's basically a whole other story, but that's also basically what's happening now, because identity becomes kind of a process distributed over you offering some documents maybe, but also basically your own behavior now, because behavior and behavioral tracking is becoming a kind of a very strong identifier. So what we've been working on is SSI, decentralized identities, with also the possibility to have disposable identities, where the disposable ID acts as an anonymous ID or pseudonymous ID and consent in the form of a verifiable claim, including all the GDPR properties needed, will travel along every data exchange. That's a bit the kind of the framework. Yes, please, the next slide. So the key that what we basically then see is a kind of a trusted or provable computing environment where you will have chips, and that chip has a virtual machine. It runs our operating system, and that's embedded in a router. It's embedded in my device. For example, it's already happening with the Estonian e-card kind of chips. So basically, I will have a phone with a particular chip. That chip runs a particular operating system running in a virtual machine. That then talks to the application and it talks to the router. So we make a triangle, and that triangle becomes a provable computing environment. And in that triangle, I can onboard any person, any item, any application, attribute-based. It means that the way that we are now in these systems, especially now with the virus and the tracking that's going on of phones with the virus, which is quite understandable. When we see two huge systems sort of growing, one a national government tracking system, one a commercial tracking system, and we need a citizen-led response to this. And our response is that we want to build a provable computing triangle with embedded security and embedded operating systems that talk to each other on a chip, and then onboarding people attribute-based only. So there's no need for exposing your full identity in that triangle. Yes, please. Well, this is, again, I'm not the technical architect here. The technical architect is, there are two. One is Jeff van Bokrijk, and the other one is Jaromil. And if you go to the next slide, you will see that basically what we are talking about is here at the moment. So it's a fully open source, secure, portable virtual machine for disposable DIDs, and it's executing human language, Zen code. It's called Zenroom. And if you go to the next slide, you'll see that if you go to zenroom.org, that is working. And this is basically a portable virtual machine for executing human language, Zen code. So what you see on screen is actually code. So if we go to the next slide, there's a movie. If you can run the movie, then the coders will know what they see. So basically, Zenroom is about cryptographic interoperability. Perfect. Okay. Yes. If you go to the next slide. This is the router, so that's daus.eu. And that's a software that's designed basically to run on any kind of a board or become a local area network moderator. So it's not only just an on-off device, but you can actually build modules for it and sort of get complete awareness in your local area network. And the way that we see it is this kind of building these enablers to get to this kind of way of thinking that next to the big ecosystems that we see, of course, with the Apple and the Googles, we want to build a huge, wide, good ecosystem running our privacy by design, security by design principles. And that's kind of a trajectory that's been going for a while. And I think, especially with the things that are happening now, it becomes more logical. So if you go to the next slide, this is basically the foundation that we're in the process of setting up, which is Disposable IT Project as a Service. And then we basically focus on the pseudonymity part in the middle, where on the left you see the government, basically the current situation where governments issue credentials and passports and sort of numbers and all these things. But this is shifting towards the right, and in the right, in the middle, you have the situation that you as a person are always able, if you go to if you see the red disposable IDs, so let's say smart contracts, that you're always in a position to prove that you own or you have some ownership over that smart contract. But from the smart contract, it's impossible to go to your core ID or to your decentralized ID. And that's the main way of approaching the current state, I would say, of Internet of Things and full connectivity in a world of huge distrust, where citizens feel that they cannot trust that environment. And as long as they cannot trust that environment, we do see uptake, and that we saw also in the first presentation, but we don't really see full enthusiasm for the space. And what we need to have is enthusiasm for such full connectivity. Otherwise, we can never get the full rewards of IIoT, which is linking up the gateways between the wearables, the body area network, the local area network, the smart home, the connected car, the smart city. As long as that is not connected through persons and objects, and as long as people don't really trust that environment, the full rewards and also the full potential things that we can achieve versus climate change are not going to happen. So we have to build a new backbone of trust and trustworthy management for this Internet of Things. And I think that what we're trying to build is an enabler for this. So if you go to the next slide, then, well, the virus, of course, was a perfect storm. So if you go to the GitHub, we started, I think, 10 days ago, March 12th. Already we made proposals, but we're also we're speaking to large retailers that are very worried about not only their clients, but also about the people working in the store with the virus at this moment. So the health ID situation is becoming huge. And I was approached by friends in China that sent me all the steps that the Chinese government has been taken very quickly into location tracking. And of course, in the first instance, location was also tied to WeChat and to Alipay, which is not the way to go, of course, in these situations. We also see these things happening now in Europe, in Spain, where we have state of emergency, and Google and Telefonica are tracking widely, and also probably in disregard of GDPR because of the state of emergency. So in these times of where people need to be quick, we also need to be principled in the sense that these quick fixes will further erode citizens' trust in IoT solutions, in their smartphones. They may even sort of try to put them away at some point if they feel that they become pure tracking devices. So what we're trying to build now is this SDK that will go on Android, that will have Zenroom at the heart of it, cryptographic interoperability, that you're able to build on top of this decentralized identity with these disposable identities inside. So I think there's another slide. I'm not really sure. I think that's it. Oh yes, how can I forget? So Council set up the Internet of Things Day, the IoT Day, set it up in 2010. And so it's been a decade now. And so it would be great if you could go to iotday.org and submit an event, which is always very easy to do. It was always about getting together and having a lunch. And now it's about getting together online, of course. And we're focusing on the virus and COVID. So thank you very much for listening. And that's it. Thank you.
Thank you, Rob. Quite a bit of information. I mean, it is definitely going to be interesting to see how the shifts in trust and social license are going to ensue that are going to further allow IoT adoption and what can be done to enable this. So I think the folks at the Council and IoT Day have got a lot of work and done a tremendous amount of work so far to do this enablement. Thank you for sharing. We're going to move on to our final presentation now. Why open source software powers innovation at the edge. And this will be given by Mr. Craig Hobbs. Craig is a senior partner engineer with Influx Data. And Craig's passions for keeping systems performing over the years have helped him to shape the kind of engineer that he is today. He's one who enjoys solving complex problems and fighting for users. His specialties include solutions architecture, project management, proof of concept design and development, software customization, technical training, ETL automation, and application integration and deployment. Craig has a BS from University of Illinois, Urbana-Champaign. Craig, welcome. The floor is now yours.
Thank you, Greg, for the introduction, and especially thank you everyone for coming to listen to my talk today. Again, we're going to dive in and talk about how open source is really becoming the software platform for the edge, as well as taking a look at some of the different solutions and use cases that open source applies to when looking at some of these edge deployments. So just to get us started here. Just just kind of quickly, I want to talk a little bit about some of the challenges that have brought this shift about to open source software. So talking a little bit about just data historians and what it all means for edge computing. And then from there, transition into where open source now plays as the key component in really rewriting this paradigm of IoT at the edge, and why there's so much value and so much excitement coming out of open source being used. And then finally take a look at a few solution options and kind of talk about combinations of open source and how you can leverage intelligent combinations of open source to address different use cases. So to kind of get started, I always like to, when I get a chance to engage with customers, with system integrators, with partners alike, is really when we're talking about the edge, is defining what that edge is. So there's so many different definitions of what you mean by edge and edge computing. Everything from I want to be able to process at the edge. I've seen definitions from Gartner, many different publications on the topic. But I always I know the definitions will cross over, so I always kind of start with the idea that we want to bring the computing power as close to the edge or on the device where possible. So the closer we can bring it down so that we can perform the processing, the alerting, the improvement, that's really the edge. In areas that may gap and have a network to it, or in other focuses, we actually get on the device itself. But really taking that power out of the traditional large data centers, large servers, and bringing it down to where it's needed by the operators, by the technicians the most. So kind of getting started with, what the edge really means. But you can't really start talking about the edge and the paradigm that is kind of IoT at the edge without understanding where we've been and kind of where we've been traditionally. And that really relates back to data historians. So when I get into conversations with customers, with working with their use cases, it always kind of starts with the idea of the traditional data historian. This is that operational technology that's been around since the 80s. So it is the system of record, the archival data that you find in large industries, from manufacturing to automotive, oil and gas. Mining, when I go into these industries, I see these systems, and it has served its purpose through those years of providing data insight and providing reports and giving operational insights. But now what we're seeing is that as the edge and edge computing evolved as that new paradigm, there's this shift away from these data historians. Being able to bring that power closer to the edge, as we were talking about, becomes more difficult. Scaling it becomes a lot more difficult. And while I've seen a lot of historian software vendors try to adapt their products, adapt the software for the developing edge, it still creates problems around extensibility and interoperability, security, being able to exchange data with other systems, other applications, really being locked into that product and being able to only have that historian, that product define your use case for you without really knowing what your challenges are with the edge. And I take that from a use case we have working with a mining company, where we actually, the challenge was that the mining equipment itself from data location would go into the mines. But unfortunately, at that point, the connectivity will become unavailable. So while they're at these locations, while they're inside of a mine, they're unable to share this information, unable to get insights on what's occurring on the mining equipment. So they have to wait till those devices, those sensors, once again became available through connectivity to then bring that information in, roll it up into their historian, their archival system, and then perform any processing and information on it. But by that time, they've missed out on all the transformations, the changes of what's occurred. So that's one of those prime examples of, while you have this archival system, this data collection system in this data center, it's broken out. It's broken because of connectivity and latency from collecting data. Oh, and then by the way, when you scale that out to all of the different machines that are now working through this mining use case, it makes it very difficult to actually work through that use case with this type of technology. And that's really where we see open source step in and really kind of rewrite the book for use cases at the edge. And what open source now provides you with is the ability to leverage different players, different technologies for addressing the diverse number of sensors and devices. We talked about trucks, we talked about mining equipment, whatever your sensor device protocol is. Open source now provides that type of connectivity to this diversity. It also allows for a lot of interoperability. So now you're not locked into one solution, one platform. You can choose your favorite platform, your favorite development approach that addresses your use case. So you're not having the use case defined for you by the vendor. Also, open source it has really made it possible for multiple industries to now take advantage of these insights. Where data historians were traditionally the playground for big industries, we talked about some. Now with open source, bigger, small targeted industries can use these. I'm seeing it go across into environment, into climate, into retail, because open source now is so flexible and allows you to really select that type of interoperability that works for your organization, your company, and as well as take hold of some of the new technologies that are being developed with some of the cloud providers, and throughout the enterprise. So open source really, really has kind of set that stage for shifting away from those traditional big vendor lockdown historians with security and interoperability, and extended that all the way to the edge. So taking a look at some sample solutions of what we've encountered, what I often suggest to customers, integrators alike, when you're looking at open source and wanting to leverage open source solutions, one of the first things you'll want to understand is what are the attributes of your particular open source, of your particular edge use case. And this goes back to the idea that if you're using something like a vendor specific solution, it tends to focus you in on using the solution in the way they've designed it. But now with open source, you can say, what are the conditions of my particular use case? Am I, constrained by connectivity? Am I constrained by privacy and security? Am I constrained by compute power? I can now take those attributes and map them to open source characteristics. And through that, I can choose the proper open source project. Open source projects are exploding every quarter. There's always something new, and there's so much innovation within open source. So you're not confined to a single large vendor that's trying to direct you down a certain path. Open source lets you be as innovative as your use case is. A couple of projects in open source that I'm really excited about that I want to share. Kube Edge is one that's really got us excited, and that kind of drives that idea of, how do you bring the proper computing power configurations down to the edge. So Kubernetes being the original cloud orchestration for deploying and running complex applications and having them managed. Now there's a complete project for bringing this type of platform to the edge. So now you'll be able to run that same type of complex configurations and software variety on these platforms that are running closer to the edge and bringing that processing in. So a lot of the benefits you see from that we talked about as far as latency and bandwidth, I can now bring this down to the edge and get it. So we're really excited about this project and what it can mean for running different open source bundles. Another project we've worked with as well in the past is the Minify project from Apache. So Minify is actually a sub-project of the Apache NiFi, which really focuses on data collection and flow processing of information. So the Minify project really provides an extensible environment for plugging into different protocols, different devices, collecting data at its full bulk, further processing that data, and then securely sharing that data with other systems. So again, kind of hitting on that idea of I can collect the data, I can collect it securely, I can share it, and I can process it or shape it based on what's needed. So making that data available to not just operators, but also a wide variety of people within an enterprise. And then finally, the Influx project. So Influx is open source time series database focused on high ingestion and high query and storage optimization. So I think it's always understood that IoT data format is time series. So we see that all the time. So what you need for that to drive so many of the objects you're trying to do, from continuous improvement to alerting to machine learning, is to collect the full frequency of this time series data. And a project like Influx allows you to collect all the data. It runs on a multitude of platforms. It can run at a very small footprint, so it can actually run on devices. We're able to install Influx on devices as small as Raspberry Pis. So again, getting the compute down to the device, down to the edge, wherever that may live, and then further continuing the processing. So just a couple of examples of some projects and solutions that we've gone through. So I talked earlier about the mining use case, and again, comparing it to data historians, and that is the idea that these large mining machines are, from a data location standpoint, unavailable to be able to pass on information. So from the connectivity to the scale to the platforms that are supported, a project like Influx allowed us to go in and actually deploy Influx data on the machines themselves. So now on the machine, not only can we collect the data, but we can also provide alerts and anomaly detections and continuous improvement as the machine is operating. Then once the machine becomes available again for general connectivity, we can roll that up, create additional reports, and even move it more, and then even move it into the enterprise with more of the cloud platform. So talking about some of the other cloud vendors that are working on IoT, this now fits right into their use case of saying, collect the information at the edge, but now bring it back to the enterprise. So something like Influx makes this completely possible with its ability to be run on the devices, themselves. Another solution, kind of taking a look at what it means to combine open source. So again, targeting the features of your use case. So in this case, if you're looking for interoperability, being able to get data from a variety of sources. In this case, I was able to take Minify from Apache and combine it with Influx. So by using Minify, I was able to easily connect securely to OPC servers, ingest that data, the full fidelity data, process it, and store it off to Influx. All of this now happening at the edge because I now have the tools that will deploy across the various platforms that are available at the edge. And now through Influx, I can further ingest that data, continue to process it, provide alerts, custom dashboards, as well as because these projects are open source and Influx is a very flexible project, add in other devices and protocols. Modbus is another one that Influx has natively included. But for everyone that may not be there, any other device or sensor, because it is open source, I can now extend it. I can now add on to it right there at the product. I don't have to wait for the vendor to add in a specific component or for them to develop it. This way, the product develops with your use case. And you can also use your favorite language, your favorite technology to bring all of this in. You're not confined by the technologies that are available only in a specific vendor product. Finally, all rolling it up to that enterprise cloud view where it can be now shared and shaped across many different organizations, from business analytics to machine learning to data science, right? Everybody now gets access to this data in a form that they can work with. So all of these things really, again, knowing your features and your categorization, you can drive that to the right combination or selection of open source software. So that's really where we're seeing the shift here. Again, working directly with so many customers, having that opportunity to really kind of say, while data historians have been that traditional system, that gold standard system, open source has flung the door open for big industries, small industries, integrators, to really now have this competitive advantage, where in the past it was just reserved for those larger industries. And it addresses all the problems that those data historians really left the operational manufacturing with when they were first kind of deployed, and that is that they were really just designed for archiving that data and giving basic reports to the operator. Now open source gives you freedom to really open that up, get more interoperability, be more cost disruptive so that you can deploy it at scale, as well as meet the requirements of your use case. Let your use case drive the requirements and the solution of what you need, and not the vendor itself. So that's it for my presentation, my talk. Again, want to thank everyone for listening in. If you're interested in more information and seeing more use cases and how Influx and other open source solutions have been combined to address IoT and IoT edge use cases, you can certainly come to our website, influxdata.com. There's lots of information on there. Also, we're happy to engage with you and kind of go through and walk you through how we might be able to address or how it might be our project might be able to use in some of your IoT requirements.
Thank you, Craig. I think real world examples are fantastic, and they're always key to broadening understanding and driving IoT adoption. From a personal standpoint, I think we got to spend an hour learning about just the mining project alone and how Influx is enabling edge capability there. So thank you once again for sharing. I'd like to transition now to our Q&A portion of today's session, where we will entertain the questions that are coming in from you folks in the audience. And just as a reminder, we have two options for submitting those today. You can use the Zoom Q&A tool here, located on the Zoom platform, and you can also submit them via Twitter using hashtag IIoTAI. Once again, that's hashtag IIoTAI. And I know many of you have reached out. The content from today's sessions will be made available after the conclusion of the virtual conference, so fear not, we will be sharing this interesting information with you folks. And in the event that time doesn't permit us to get through all the questions, we will carry this conversation over to the social media channels via Twitter, and once again with the hashtag that I mentioned, IIoTAI. So let's move into some of the questions that are coming in. This came in from Siva Subramanian. It says, how about connectivity concerns, 5G, IORA adaptations? Any comments there from any of the speakers?
Well, maybe quickly, the way things are going also with 5G and also the political situation. I think what we see now is that there's some kind of smart city solutions that think in terms of cold spots and hot spots, and so you have situations where you have cold spots, no connectivity, like the normal connectivity that we have now, and then you have your 5G where you can do your AR, your VR, and all these things, and so it's more like trying to gradually bring the strength of 5G into certain cases instead of just bringing it to the entire ecosystem, bringing it to the entire world, sort of at the same time. So I think I would like to think in terms of hotspots of 5G and actually show some real value there first.
Very good. Thank you very much for that. Now, Prasad has a comment as well. He says he's getting into the nuances, the minutiae here, so bear with me 1 second. But Prasad's asking, he says, very good data, and could it be shared with the public on the outcome of the survey? This is good takeaway number 11. So I think this was back from possibly yours, Rob. It says, doesn't total 100%. There's about 40% missing. So he's curious about what other buckets that information fell into from deploying IoT solutions perspective.
I think it's Frederick's presentation.
Frederick, okay.
Yeah, absolutely.
Yeah.
Sorry about that.
It was
routing into the wrong guy.
Yeah, incredible data though, Frederick. Really very, very insightful and actionable. Thanks. Yeah.
My pleasure. And well, that's our duty, I mean, as a vendor-neutral nonprofit organization to collect and disseminate data like that. But essentially, the case of slide 11 is that we are just displaying the top 3. So for the rest of the 40%, we have that data. But this is something that we open to our members. So, but overall, you know, if I have a look right now on my screen on what we found, let me. Yes. So essentially, in the case of slide 11, the rest of the information covered a wide variety of concerns. So it was spread over maybe 10 or more other entries. But in the other concerns that we saw, certainly connectivity was another big one. The fact that you have so many connectivity options, you know, -7, LoRa, Wi-Fi, Bluetooth, you know, you name it, is certainly another big concern. And then obviously the complexity of deployments was another big concern, and this is something we are trying to address at the foundation by exposing Helm charts, for example, for our variety cloud-based backends, at least, so that it's easier to work with them. Development tools was another big concern in the sense that you have to manipulate lots of different tools right now to do edge deployments, and one of the goals of our Edge Native working group is to provide tools that will streamline the process, especially in the case of mass deployments, etc., etc. So that's the kind of information that we had that's not shown on the slide.
Oh, thank you, gentlemen. I've got a question from Vimal. He's asking, this is to Craig, he says, how is Node-RED different from Minifee?
Yeah, no, Node-RED is yet another great project. Influx also integrates with that and use plugins for that. So in many ways they're the same, kind of giving you that classic ETL for IoT. What we've seen with, at least with, each one has its pros and cons. I think Minify can be heavier than Node-RED. Node-RED's really light. Again, when you're talking about compute at the edge, you want something light. But what we have worked back and forth with each. But again, it goes back to that note of what is the use case you're trying to solve and mapping your specific attributes. So in the specific case of Minify versus Node-RED, it was security that was very important in that use case. So, and we've kind of talked about where security ranks as far as IoT and industries and manufacturing using that. There was a level of security provided by Minify that wasn't available in Node-RED. So we decided to go with that project for that particular setup. But again, given what drives your attributes, Node-RED would be an excellent alternative. And I think much lighter weight than something like Minify.
Got it. Thank you, Craig. Scott's got a great question that I know comes up at a macro level to us a lot of time based on our community. So for smaller manufacturing companies with limited software departments and skill sets, is open source still feasible, or is a product as a service, PaaS, more desirable?
That's a very good question. It really depends on the use case, but my gut feeling there would be you can certainly have the best of both worlds by finding a commercial provider who will rely on a core of open source software. And in fact, we have several of our members that are doing that. So I suppose for a smaller organization with limited skill set, that would be likely the best way to go. But, I wouldn't generalize that. It's really on a case-by-case basis, and it depends on the market segments, what players are in there, and what kind of open source software is available to address the specific vertical we're talking about.
Got it. Okay, thank you. One more question here. This one's from Prasad. It says, placing gateways at strategic locations is an important aspect to edge-based. Do you have any thoughts on any work around IoT deployments in really large plants? And I know you highlighted one in mining, but and how do you overcome any of those challenges? So maybe speak to some of the things that came up in the mining side of things.
Yeah, so strategic placement of your gateways, does drive a lot of that data collection and aggregation. And again, the goal is to bring the processing as close as possible. So at least in that use case, that real world situation, the gateways were actually rolled all the way up to a centralized server. So we started doing a lot of fog computing, if you will. So now you have more gateways, and then you have fogs kind of bringing it all the way up to the cloud. So that was one approach in that particular real world situation. But I understand the concern, and the way we really try to approach that with open source again is to look at where you live and drive for your specific requirements, and we can help you with that. And I think that's part of what we do in the open source world, is that we do consult for you, really kind of provide some of the best practices of using different open source combinations. But I think we used some fog gateways when we were addressing that particular use case.
Got it. Okay. Now, Mohammed has this is more of a general question. It says, can you consider a PLC as an edge device?
Interesting. I would say in most cases, no, because typically, I mean, the PLC is something that's really something that will, you will drive robots, you will drive industrial processes through a PLC, and your edge node will, in the best of words, collect data and aggregate locally and that kind of stuff. So although you could, if your PLC has enough firepower, I guess maybe you could aggregate data from neighboring PLCs and stuff like that. But I would, well, once again, we are talking about abstract things there, but thinking about a real world scenario, I would rather prefer to have a distinct edge node from a PLC, because essentially if you have to maintain that PLC or replace it for whatever reason, you don't want to disrupt your edge operations for other PLCs that will be on the floor as well. So my advice there would be to have proper separation of concerns between, on one part, a physical object in your factory that's doing a task for your production process, and on the other end, the edge infrastructure. But maybe Craig, you have a different answer to that one?
There's always a bit of a gap of what someone considers IoT, at least what I found. Is it any sensor? Is it any device? How do you define what a IoT device is? What we have found in some of our real world deployments is that the actual PLC can be, at least in their use case, can be considered an edge device. And now communicating with that particular controller is key. And in many cases, it gets rolled up into an OPC server, and we're able to access that. In other cases, it's just an individual device that we have. We can write custom protocols to connect to it based on what developer said, or what supporting software you have in your factory. But I would say, just kind of my short answer on that is we've considered it both ways. And again, it's really driven more by how you're set up with your factory and your manufacturing. How do you want to position that device?
Got it. All right, thank you. Ritu's got an interesting question, or I guess maybe noting a point. So he's asking, the top 3 concern priorities don't list connectivity. So what are the thoughts around that? Is connectivity addressed? Is it not really an issue?
No, it's certainly an issue, but in this case, this was the commercial adoption survey, and we tried to keep the questions at a bit of higher level than what we do in our developer survey. So the last edition of our developer survey showed effectively that connectivity is a high level, very important concern for IoT developers. And the explanation is pretty simple there. I mean, with all the wealth of options that you have, finding the right one, the one that will be effective at the technical level, but cost effective as well, is something that's sometimes difficult. So yes, connectivity is pretty high. It's just that it doesn't surface in the same way in our commercial adoption survey versus our developer survey that we did last year.
Got it. Okay, thank you for the clarification. Hopefully that helped. Oh, I've got another interesting point here from, where did it go? Hold on one second. Here we go. Liviu is bringing up points. Says the majority manufacturing floor devices are Ethernet IP. So how do you interface with an Ethernet type of an application in an industrial environment? And second to that is, how costly can this be for, let's say, a 500 input-output point type of an application?
Yeah, so from some of our experience, at least for interfacing with that, we've had standalone open source loggers that are able to interface with Ethernet IP. And because when you're talking again, when it gets to the scale of the scale of the cost, that's really where open source gives you a huge advantage, because you're not confined. Generally, when you're thinking about cost and other vendors, their cost model tends to be around how many collections do you deploy, how much data are you collecting. But open source doesn't. The open source cost model is far more disruptive. It doesn't base it on that. So with something like that, we certainly can point you towards some open source loggers that we have for connecting to those types of devices, and the cost model would be really based more on is based on nothing more than your ability for a one-time setup.
Got it. Okay, thank you, Craig. Now, I think Christoph's actually got a similar question, but maybe a little nuanced, different. He says, when you're taking an example, if you have disconnected or independent devices like mining trucks, what are good technologies or techniques to get the collected data to the cloud? I hear crickets.
Yeah, no, absolutely. Well, that's a deep one. but certainly, well, that's the thing. I mean, the whole I mean, when designing an IoT solution and one that integrates edge components, the fact that the network won't be reliable or at times will be cut off, literally, is part of the basic architecture and design. So in this case, I mean, edge computing in any disconnected scenario is helpful because having an edge device that will collect data locally while the network is gone is certainly helpful. But then depending on the constraints that you have, the kind of sensors, the sampling rates, the kind of use case that you have, then maybe you will need to expand on you know, that very basic answer, and then you will rely on different techniques. But there's no one-size-fits-all solution in that case. It's all about the use case and the constraints that you have, and the latency that you can endure, so to speak, depending on the application. Because if this is an oil and gas refinery and you need to close that valve in 5 seconds, otherwise the whole situation, the whole site blows up, it's not the same thing as, oh, I need to monitor this self-driving truck and maybe there will be blind spots in network coverage, you know, on when it goes underground, for example, that kind of stuff, right? So yeah, we talk more detail about the use case. That's what I would say at this point.
Okay, no, fair enough. But you want to comment, Greg? Go ahead.
Yeah, I would just add to that. Couldn't agree more with that. It really is dependent on the use case. I know from within some of the use cases we've worked from using something like a time series database, because the data all comes in time stamped. Things like connectivity and latency, when you do roll the data up to something like your enterprise cloud. Because it's organized by time, that really allows for that type of aggregation. So connectivity and latency become less of a critical element. Once I've collected the data at the edge, when connectivity is available, whether it's fairly spotty, all the data that once it is eventually rolled up to the cloud, it'll be organized by time. So you as a consumer of the data won't know, it won't really feel that effect, because the data will always be there and properly aggregated as it continues to come in and as connectivity improves. And we work with, and so much so with open source, cloud providers like Amazon and Azure and Google alike, they have their IoT hubs. They're working with open source technologies now. So while they are presenting all of these tools for aggregating and collecting that data in the cloud, their forward technologies connect directly to it. So for something like influx data, we're able to collect that from a mining truck, from a SCADA system, and through limited connectivity, roll it all up there. And again, it's all organized by time. So there's no problem with the data coming in spotty or in batches.
Got it. Okay. No, thank you both for the clarification and addressing that one. Got another one. We may be able to field this. We may want to take it offline with these folks too. But Vasudev is asking, he'd like to know some good case studies using open source to manage the edge and cloud services for energy management, so small, medium, large buildings specifically. And he'd like to learn more about how the open source community and certain suppliers, startups can help them in their journey. You know, partnering with a couple different OEMs for, you know, providing the hardware side of things. So can anyone talk to, I guess, the energy management side of the equation and leveraging open source?
Obviously, I'm sitting at in a lower stratum of the universe, in the sense that the work we do at the foundation is about basic building blocks for IoT, but we have a few vertical applications in our portfolio, and one of them is called Eclipse Voltron. So Eclipse Voltron is something that comes from the Pacific Northwest National Laboratory in Richland, Washington, and this is part of the US Department of Energy. And essentially, we have a few of our members and other players in the industry that are leveraging that for digital building, connected building energy management. So I would advise you to go to voltron.org and have a look at this, because this is a fantastic starting point as a all-inclusive platform for energy management, not just for digital buildings, but it can be deployed for that. And PNNL itself are managing their 18-building campus in Richland, Washington, with that solution. So it's certainly scalable enough.
No, thank you, Frederic. I think probably another point to reach out to would be the folks at NREL. I'm sure somebody's got that on their radar screen. The renewable energy side of things, but that's one of their main focal points too. I think that's nrel.gov. So good questions. Let's see here. We got, okay, this just came in from Rugos. Let's see how, okay, about data security and the concern of companies cause of that. In what percent different situations may occur? It says DDoS attack is a big concern for a SCADA system. Or a data gathering exposing data is a big concern, or remote manipulation of a field device is a bigger one. Any pi or percents on occurrence, and also any level damage. I think he's trying to get at what the vulnerability of SCADA systems here. So does anyone want to field that one?
Well, the one thing I can say about this is essentially that obviously running an IoT solution doesn't mean necessarily that you will run it over publicly accessible networks, right? So proper network segmentation is an important concern in any solution, whether it is a factory or a set of oil and gas wells in the middle of nowhere. But certainly that a tricky thing, especially when you consider SCADA and older solutions, because SCADA is not a new thing, right? It's been around for 20, 30 years. And when you have older PLCs on your factory floor or in the field, one problem is that they are using old unsecure protocols and that kind of stuff. And then the best way to handle things is certainly to keep those older, more vulnerable components out of the public network. And then to ensure, using edge computing, for example, that you use proper security, until the edge. So network segmentation and proper clearance of the traffic is certainly important there. Yeah, I think we could do a whole virtual conference about those kind of concerns, isn't it?
Well, there you go. We got planting of the seed for future engagements. I love it.
Yes.
Well, hopefully that gave you some points to grow on. Let's see. We have. Okay, I'm just scanning this one. Okay, Olivia has a question here. It says after we have the data in, captured in some way, shape, or form, management needs reports. So do you have pre-configured reporting that can show OEE and other types of information that's going to be pertinent to the upper management of an organization?
So I would say the short answer is yes. So there are already so many efficiency reports we have pre-built as part of that, as part of the solution. And again, you'd probably find this amongst so many different solutions. In fact, in open source, so many OEE reports themselves are themselves objects and can be exchanged. So what we find often is when we go into these solutions, if there's not already an object we have available in our archive, we can export from other systems. Again, that's that interoperable nature of it all. Go build it in your own favorite system. We'll bring it into ours. They're just JSON objects. Bring it into ours. Or you can build your own, and that's really where a lot of our work starts coming in with SIs and partnerships, where they'll take open source now and put together a series of templates and solution deployments now targeted. They'll still combine the best of open source, Node-RED, NiFi to the cloud or not, but now they'll build directly to use cases where they have domain or SME expertise. But short answer is yes, we have them. Just depends on where you want to go with it.
Got it. Thank you, Craig. So I'm going to wrap up with one final question here. This is, so on data security, while using such open source as part of an OEM offers, how well is the community supporting to fix vulnerability, and how fast can it be fixed, and how can we rely on the open source community? Is there some governance principle, a board who supports while using open source for cloud and edge? So it sounds like Vasudeva is questioning about, you know, who's got his back when these things are being implemented. Is there somebody to reach out to, or from a community standpoint, being that it's open source? I'll throw that out to all three of you if somebody wants to address that.
Yeah. Well, this certainly highlights something very important, in the sense that not every open source is the same. And by that I mean, there are maybe 10 million or more repos on GitHub. So how do you pick what you will build your commercial product or business on? And to me, the answer is the best open source components are the ones that are managed through neutral third parties. Like Kubernetes, for example, doesn't belong to Google anymore. It's part of, you know, the Cloud Native Computing Foundation, which is under the Linux Foundation. And ideally, you will go for components that are supported like by third parties that are neutral like that, because then, I mean, it's you have a neutral governance, you know, in the middle between the project committers and then the rest of the community, that ensures that you know, a level playing field is maintained, and, you know, all potential contributors have the opportunity both to contribute, and at the same time that none of them can take full control of any specific project. And this is something like what we do at the Eclipse Foundation. We are that kind of third party, but there are other players in the space like Apache, the Linux Foundation, and others. But typically, if I am to build something on the top of open source components, I will look for something that belongs to a neutral organization like the ones that I just mentioned. And obviously Eclipse is the best one, right?
Mm-hmm.
So if you look at, for example, Drupal, that the way sort of this is happening, then there's a massive developer base, and of course reputation is important there. But then there's also all layers sort of on top. So for example, if MTV wants a module done in 3 months, then this can be put to the community as a paid job, and then after a few months, the whole module becomes open to the whole system, to the whole environment, and then there's a consultancy layer. So it's very important, I would say, to look at the strength of the ecosystem of the domain which you're choosing, and who's in there. And can I just ask you a quick question to Frederick? Just very quick, so maybe, because I think is very intrigued by this, the 30% under the 100K and the 5% 10 million sort of, and they of course need to be addressed very differently.
Yes.
And so do you have tools for this? How you are managing or looking at this, or how are you approaching this?
Well, obviously it's once again the one thing I like about our survey is that we've got a fairly sizable number of people who answered it. The one thing I didn't like is that in some cases, when we designed it, we didn't foresee the need for some additional data about some of the questions. And that one specifically is an important one, because, well, the amounts in themselves don't tell us much, in the sense that in IoT, you can deploy, you know, you can go a very long way with about 100K. In the sense that, you know, boards, microcontrollers, sensors can be very cheap, right? Yeah. And you can have a fairly sizable deployments with them, especially if you already have the backends that you need, or the backends that you need are open source, so you don't have any licensing costs for that. And then on the other end, certainly that a deployment of 5, 10 million or more is certainly sizable, but then what's the actual size of the thing? And that's why in the next edition of this survey, we will certainly dig deeper and try to correlate the amount with the number of devices or the number of sensors or that kind of stuff to get a better idea. But one thing is sure, leveraging open source is partly about the cost. And this is a question we didn't put in my presentation today, but we were asking people, why are you picking open source versus commercial? And cost wasn't the first answer. The first answer was flexibility. The fact that you have full access to the code and full control over what you can do with it is more important to people than the cost savings, although cost savings are always nice, isn't it? So yeah, that's what I can tell at this point with the data that we have, but certainly we will dig deeper there. But I'm curious, maybe the other panelists have insights about what they see in their own businesses about this.
Thank you. Yes, very clear. Thank you.
Well, I think that sounds like a very interesting point to end on. So I want to thank everyone for taking the time to join us today, and a special thanks to our speakers as well. And please stay tuned for other educational webcasts brought to you by IIoT World. If you haven't done so yet, make sure to mark your calendars for June 30th and July 1st to log in for IIoT World Days. It will be the largest industrial IoT virtual event in the world, a 2-day summit dedicated to accelerating the rate of adoption of industrial IoT globally. We currently have over 5,000 registrations, but make a special note to register now for free at www.iiotday.com and save the $499 registration fee, which is going to go into effect very soon. So although our collective ability to attend live events for the foreseeable future is for a large part on hold, our mission to help the world expand the adoption of industrial IoT is not. So in these unprecedented times, we invite you to reach out virtually to share your thoughts, stories, and ideas with our editors, analysts, and co-founders through the following links. As soon as travel becomes an option again and global events around industrial IoT resume, we will look forward to resuming in-person meetings with each and every one of you that reaches out. Special thanks to our sponsor, Influx Data, for today's educational session, and to our speakers, Frederic, Rob, and Craig. Outstanding job, gentlemen. Thoroughly enjoyed it. If you have a suggestion for a topic or otherwise, we always welcome feedback, so please drop us a message and let us know. And if you like what you heard today, we invite you to subscribe to our newsletter, YouTube channels, and follow us on Twitter at IIoT_world. That's at IIoT_world. This concludes our program for today. Thank you for joining.